Hi, welcome to Zona Mechanica. There is an MCQ on bending moment. Actually, there are two questions based on same data, and the two questions are of linked answer type, and the common data is given as a massless beam has a loading pattern as shown in the figure. The beam is of rectangular cross section with a width of 30 millimeters and height of 100 millimeters. The question is the maximum bending moment occurs at option A location B, option B 2675 mm to the right of A, option C 2500 millimeters to the right of A, and option D 3225 millimeters to the right of A. Well, as you can see in this figure, this is the beam, okay, and it is loaded at half portion with a UDL of 3000 Newton per meter, okay, and the entire span is 4000 millimeters, that is 4 meters, okay, and this figure at the margin indicates the weightage of the question, that is 2 marks, okay. This is the beam, and this is the point A, and this is the point C. Clearly, at these two supports, there will act two reactions. Let RA and RC be the two reactions, okay. And we can assume this UDL as a point load W, which will act at the mid span, that is at 1000 mm, that is at 1 meter from B, okay, that is at 3 meters from A, okay. So W will be equal to 3000 into this span, that is 2 meters, okay, this much Newton, that is 6000 newtons, okay. So clearly Ra plus Rc will be equal to 6000 Newton, okay. So taking moment about A is equal to 0, so this will imply that W into 3 minus Rc into 4 is equal to 0, which implies W is 6000 into 3 is equal to Rc into 4, that is Rc is equal to 6000 into 3 by 4, so 4500, okay. Therefore Ra will be equal to 6000 minus 4500, that is 1500 newtons, okay. Now the moment, let us take a section XX over here at x distance from the end A, okay. So the moment at section XX will be equal to Ra into x minus, so this much portion of loading will be there, okay. So if this is the XX section, then this much load will act, okay. So this is x minus 2, right, this is 2 meters, so this portion is x minus 2, right. So x W, that is 3000 into x minus 2, and this is the load, and distance is this x minus 2 by 2, this distance, okay. So into x minus 2 by 2, that is we can square it and divide by 2, okay. So that is Ra into x minus 1500 x minus 2 whole square, okay. So this is the expression for bending moment. Now the bending moment at the point B, MB, will be equal to Ra is 1500, so writing 1500 into x is 2, from the point A to point B it is 2 meters, okay, minus 1500 into, okay, so it is 1500, so we can write over here 1500 So if we take 1500 outside, then x minus 2 whole square. Okay, so here x is 2 and 2 minus 2 whole square, so that is equal to 3000 Newton meters. Okay, MB. Now another option is at 2675, that is 2.67 meters. Okay, so this is 1500 into x means 2.675 minus 2 minus x minus 2, so 2.675 minus 2 whole square. Okay, so this will give 3329.06 Newton meters. Okay, and this M2500, that is 2.5, will be equal to 1500 2.5 minus 2.5 minus 2 whole square, so this will give 3375 Newton meters. And now the last option, M3225, that is 3.225 meters, will be equal to 3.225 minus 3.225 minus 2 whole square, so this will give 2586.56 Newton meters. So clearly, out of these four options, this one is the highest value, 3375. Okay, so this is the maximum bending moment, so the option C will be the correct answer. Okay.